How are you? Today we will talk about the second session about integration. We will have examples only. Last time we talked about rules. Let's today talk about putting these rules together. So let's start with this example. The one on the top. What's the integration of 5 over x squared over 3 over x minus 2x minus 7? Now, do I need to rearrange? Well, I've got to rearrange this. So it's going to be 5 minus 2. This cannot be averaged. Why? Because if it goes up, it's minus 1. Minus 1 plus 1 is 0. So actually, this is the integration of that is ln. Remember that one. This is ready, and that's ready. Therefore, the integration of that, minus 2 plus 1, minus 1 over minus 1, plus the integration of ln of 1 over x is ln x. Why this one? Because absolute means ln takes only positive values. If you forget, it's okay, but in general, and 2, the x power 1, you add 1, it's 2 over 2 minus 7x. And remember, never forget the c. It's called integration constant. We can rearrange this. Negative 5. This will go down again. And there's nothing here you have to rearrange. And that one, oh, the 2's will cancel out. And then minus 7x plus c. This is the simplest thing you can see that. How about we look at the second question over there? 7 over 3 over 7, the fifth root of x squared minus the square root of 3x cubed. In such a situation, my advice to rearrange the powers. This can be written as a power of 2 over 5. And that one should be split separately, each one of them alone. And this means what? X power 3 over 2. So I can put it like that. X to the power 3 over 2 dx. Am I ready? Not yet. This has to go up. So 3 over 7, x to the power 2 over 5, but it's negative. And minus square of 3, x to the power 3 over 2. Now I'm ready. For what? To integrate. The integration of this one. This as a constant, it stays. X minus 2/5. How much is it? It's a plus 1. Alright? So minus 2/5 plus 5 over 5 is a plus 3 over 5. Don't forget, divided by 3 over 5. Minus square root of 3. 3 over 2 plus 1 means plus 2 over 2 plus means 5 over 2. 1.5 plus 1 is 2.5. Divided by what? 5 over 2. You probably can leave it like this, but my best advice, this will cancel out, this will go up, there's gonna be 5 over 7 x to the power 3/5 minus, this will stay, nothing cancels out, but this will go up, 2 square root of 3 over 5 x to the power 5 over 2, and don't forget, as usual, the integration constant. Alright, so simply the rule, add the power 1 and divide by itself. Why can't we take other things that we've learned last time? Now we're doing video 2-3. Last time we did video 1-3. Alright, let's take this one. 3x squared minus 4 when it's multiplied by x minus 2 dx over 2x. Simple algebra. Without simple algebra, sorry. Let's expand the bracket. This time this time that. So 3x cubed minus 6x squared. And this time this time that. Negative 4x and the plus 8 over what? 2x dx. Can I simplify further? Yes, I can. How? This divided by this is 3 over 2x. Why x? X cubed over x, x squared. 6 over 2x over this, negative 3 times x. Why? X squared over x is an x. Minus 4x over 2x, it's a minus 2. X over x, they go away. And at the end, 8 over 2x, it's a 4 over x. And this is what? This is the ln one again. Wow. So Integration of this, x cubed over 3 minus 3, it's 1 plus 1 is 2 over 2, and the integration of negative 2x, like we said in the first example, and this is simply, it's a plus 4 ln x plus c. You could simplify that, that's a good move, but at the end, that's it. Simple example, straightforward, watch all the algebra. All right, ladies and gentlemen? Let's look at example number 4. That was example number 3. Now example number 4. It's all exponential. 3 to the power 2x minus 8 to the power 5x. How about if I say plus 4 to the power of x times 5 to the power of x, and plus 12 to the power of x over 2 to the power of x, at the end of the game, minus 2 to the power of 5x over 4 to the power of 2x, all dx. So what do you know this question? All about basic exponential. Can I simplify anything here? I think we need to simplify the last 3. So let me leave the first 2 alone. 3 to the power of 2x, we know how to do that. We'll talk about it. E to the power of 5x. Since the powers are the same, we can multiply the base. So 4, 5 times 5 is 20x. When we divide, if they have the same power, we divide the bases. So 12 divided by 2 is a 6. This is a naughty one. I can think of that like this. And to the power 5, 2 times 2 times 2, 5 times, which is 32. And 4 squared, 4 by 4, 16. Oh, same power, divide the bases. 32 divided by 16 is a 2. So now again, it's a minus 2 to the power of x dx. All right, gentlemen? Easy, straightforward. You can see that one how it's done. If they have the same power, we multiply the base. When we divide for the same power, simply we divide. So what's the integration of that one? I don't know what to do. I can think of it that way. Look, 3 squared to the power of x. And that's 9 to the power of x. That's a smart move. Therefore, here I can simply put 9 to the power of x. Now the rule is clear, straightforward. To do that, this is 9 to the power of x over ln. 9? That's different. This is what's called e. So e to the power of 5x, the derivative of 5 over 5. 20. It's a 20 to the power of x over what? Ln 20. I've shown you this last time in video 1.3. And the last one, 2 to the power of x over ln 2. There is no need to find what's the value of ln. Make it simple, make it constant, make it exact. All right? How would you follow up with me? Am I fast? Yes, I'm fast, but what can I do? The best way for you to stop it and do it again. That's the best way to see things. The faster the better. All right? Now, ladies and gentlemen, let's look at example number 5. 2 secant squared 5x minus half secant 4x tan 4x dx. So, I don't have to memorize these ones. I can have these rules somewhere. Use your worksheet, lecture notes. In your lecture notes, you would see what? You will see the rules. Just use the rules, for God's sake. I don't remember anything. If I am in the exam, I will be given these rules. If I'm at home, I can use them. So don't feel bad that, I don't remember that one. So what's the integration of secant squared? I remember the tangent, derivative secant squared. So the reverse, oh, this is tangent. What is the angle? Never touch. What's the derivative of 5x? And don't forget my 2. So, whenever you have tangent 5x, 6x, you take the derivative of the angle. Clear? Now, this has a rule. Check your lecture notes 8a. You will find the rules in red. All right? They are in your lecture note. So if you see secant tangent, what is the integration of that? I am looking at the rule, and the rule simply is secant only. So the rule for that one, secant 4x. I forgot something. What is the derivative of the angle? 4. Can I simplify this further? Yes, why not if you wish? 2/5 tangent 5x. You could put it between brackets or you don't have to. 1/2 times 4 is 1/8 secant 4x plus my constant c. So you have 4 rules that cannot be remembered. You can use your calculator to find any missing answer. Alright guys, gentlemen, ladies, يا بنات كيف حالكم? Alright, let's take one last example, little bit funny. Let's call it number 6. ax squared minus b all squared dx. A and b are constants. Think about them like 2x. So what can I do to do that? I have 2 different ways. I can have the long way or I can have the short way. The long way is to rewrite it like that. Multiply it by itself twice. If you're good with expanding the bracket, you are a very happy man. I just expanded it. I can simplify it further. Don't forget the a and b are constant. Minus 2ab, it's a minus 2abx squared plus b squared. All of these are called constant. I am integrating this function with respect to x. My x is the variable. So look at the x and then add 1 divided by itself. All right? This is the x. 5/5. What is that? Leave it. It's a constant. Minus 2ab. Oh, squared plus 2 plus 1, 3/3. And the b squared, just a constant like 5, 6, 7, 8. So what is the integration of 5, 6, 8? 5x, 8x, 6x. So plus b squared, x plus c. All right? Yes, you can have it that way. Can I do it another way? Well, this is the key for the other question, for the other step I want. Let's say I'm going to do question 6 in a different way. ax squared minus b squared dx. If I want to do it, star means another way. I would leave that the same. The power 2 like power to the power 3 over 3. Oh my God. And what's the derivative of the inside? The derivative of the inside is an a times 2x plus c. Now, we have a problem here. The one inside is not linear, so we cannot do that. Remember that thing. Well, but you just solved it for us. I said, no. I said, is there another way? I said, let's try it. But what I want, actually, is to give you questions like that. Am I crazy to do this like that? I have to multiply 3x by plus 7 9 times. But the good thing about it, that the inside is linear. What do you mean by linear? I mean by this is power 1. So remember, don't mix up between anything you want to do except it's being quadratic, don't do it, or more. So simply that one, very easy. 3x plus 7 power of 10 divided by 10. And what is the derivative of the inside? 3x is a 3. So now you can simply say 3x plus 7 power 10 over 30. All right? So remember, you don't have to expand this 10 times. Even if you see a question with to the power 3, you don't have to expand it. For example, 5 minus 6x to the power 3. I know you want to be smart. I know you want to show off. I know you may have to do it that way. No, you don't have to. Simply is take this one. 3 plus 1 is a 4, divided by 4. And what's the derivative of the inside? 5, 0, negative 6. The minute you put x here, it's invalid. Very higher level than what we need. So simply what we have here, minus 1 over 24, and it's a 5 minus 6x to the power 4 plus c. That's the best thing you can go for it if you really have a problem with anything else. Sometimes we have some little special cases. Like what? Let's take this example. One of the things we did so far is that the integration of 1 over x is len. How about if you do something like that? 5x squared minus 3x plus 2. This is a fraction. This is the denominator. I'm going to have something at the top like that. What do you notice? There is some kind of relationship between them. The derivative of the denominator is up there. Oh, so what I do? Simply the rule is the len of the denominator. If and only if its derivative existing over there. If the derivative of that is up there, take the len. And that's it. You say practice makes perfect. Look at your lecture notes, please. Can I make it a bit hard? Yeah, sure. Look at me. Example number, I think, is 8. I'm going to put here 5x squared minus 5x plus 7. And what should I put there? For example, I'm going to put there ask yourself a question. What is the derivative of 5x squared? Supposed to be 10x. What is the derivative of minus 5x? Well, it's supposed to be minus 5. 7, 0. What do you notice there? I played a game. I took common factor and then this is what I have left. But I don't have 5 here. Assume you have a 5. Well, don't take it as a yeah, you have a 5. Let me leave the 5. All right? So, the answer will be 1/5, assuming that was there, I'm counting that for it, times len 5x squared minus 5x plus 7 plus c. This is a little tricky one. It's easy. Anybody can see the game. Why? Because 5 times 2 is the derivative of that. 5 times 1, derivative of this. But it's not there. So if you want to count for it, in a high level, we call this integration by substitution. But I can do it by inspection. Some people don't like inspection because it's hard to see. It's okay. Practice, practice. Don't worry about it. Last question, I want to finish everything here. How about if you see something like this? Question number 9. 3 over 5x plus 8 dx. Why don't I leave the 3 out? Because the derivative of that is not there. What's the derivative of 5x plus 8? Well, it's 5. I don't see the 5, so multiply it out. So, the integration of 1, remember at the beginning we said, what was the integration of 1 over x? We said len x. This is the same one. And instead of x, 5x. So, it's len 5x plus 8. If you wish, forget about that one. Some people don't like me. I know you hate me by now. Divided by the derivative of whatever inside is 5 times 3. It's the same. Whether I put 1 over 5 or I leave the 5 down. It doesn't make a difference. No. Should I forget about kind of this smart ID code inspection? Yes, you can.